Okay, so today we're going to work with section 4.5, 2-column proofs. Before we start proofs, let's discuss a little bit about their purpose. Proofs prove why you can come to a conclusion. You're going to have statements and reasons that are written in a very specific order, and they must follow a logical pattern. For example, how would you tell someone to make a peanut butter sandwich? Think about that for a minute, and then let's watch this video that I got posted here below.
You're not making any sense. He's already ruined it on purpose. He knows how to make one.
What's up, the internet? You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah.
Then do it.
I knew we were gonna do this. I heard Dad talking to Mom.
Choke yourself on my hand. Sometimes they do what you tell them.
Dad, I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite. This doesn't taste like a peanut butter jelly sandwich. Fail.
Yeah. Oh, yeah. Sorry, I had to make it extremely specific.
Oh, good. I'm starving. Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop a bit of peanut butter out of the...
That means like a lot.
A bit means a lot?
In my world.
Spread your scoop of peanut butter onto 1 of your pieces of bread with the knife. All right? There we go.
You're doing better than before, though.
Open the jelly jar. Squeeze it onto the other piece of bread.
No.
Done. Closer. Get 2 pieces bread. Get some peanut butter. Take the peanut butter knife. Open the peanut butter. Put the knife in the PB. Get some jelly. Open the jelly.
No.
Squirt the jelly onto the bread. Take the butter knife with the peanut butter on it. Wipe it all over the piece of bread that's blank. Take the butter knife, rub the jelly all over the piece of bread.
Oh, he's doing better. Oh.
It says all over. Put the 2 pieces on top of each other.
This isn't how I meant.
Take 2 pieces of white bread out of the bag. Take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto 1 of your pieces of bread with a knife.
No.
Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done. Get 2 pieces of bread. Get some peanut butter. Get some jelly. Open the peanut butter. Get a butter knife. Put the butter knife in the peanut butter. Take the butter knife out of the peanut butter.
You did it wrong. No.
Take one piece of bread and take the butter knife that has the peanut butter on it and spread it all over the top of the piece of bread.
Dad,
That's the top.
I mean the sides.
Squirt some on another piece of bread. Take the butter knife, rub it all over the top of the piece of bread.
I quit. You're not making any sense. Sorry, ruined it on purpose. He knows how to make one.
I know, Evan, it's the joke. It's the game that we're playing. Oh.
Do you know how to eat a piece of bread? You want to take your sandwich with you?
Oh, this is really so good.
It looks like a yummy sandwich. I'm glad I made that for you.
Can I not save one with it?
Yeah, go take that one to mommy.
Okay. I edited a bit.
Take 2 pieces of white bread, take the lid off the jar of peanut butter. Get a butter knife and stick it inside of the peanut butter jar. With the knife, scoop some of the peanut butter out of the inside of the jar. Spread your scoop of peanut butter onto the face of one of your pieces of bread with the knife. Squeeze some jelly onto the other piece of bread. Spread the jelly on the bread with the butter knife. Put your 2 pieces of bread, peanut butter and jelly sides together. Done.
Now eat it.
Not the best,
Well, you made it.
but
so
I think it qualifies. That's a win.
Woohoo!
Well, Evan and Jonah, did that go as you expected?
Yes. I expected to win.
Well, you sort of won. But really, I feel like we were all losers. Did you guys have fun at all?
Yeah.
There were at least a few points where it seemed like Evan was kind of having fun.
He's like, I don't know, nothing.
Okay, so now hopefully you see the importance of the order that you say something and the details in your directions. How does this apply to 2-column proofs? Well, a 2-column proof will have the following: a statement of the actual problem, a diagram marked with given info, restatement of given within the proof, and the given will always be the first reason. That will be very important. You will have complete supporting reasons for each step in the proof. That's like the instructions. The congruency statement will be the last. Those shortcuts that we've learned about is going to be your last reason for your proofs. So here's an example. Notice this diagram. There's some given information over here on the side. And then what we are trying to prove is also stated. Notice that what we're trying to prove is the last statement. That was the point of everything. And our shortcut is the last reason. Also notice that our first statement is what we were given. And we start with what we're given. We think about how we can use that to make other things become apparent. An endpoint divides something into 2 equal parts. If you notice, Ln is congruent to Nw, Sn is congruent to Nk. Those things come from our previous statements. So our statements and our reasons kind of go together. Like, we couldn't say the definition of a midpoint without giving you a midpoint first. Now, most of these things are going to be a mix and a match, or a choose the correct option. Most of these problems, I don't think I give you any problems where you have to come up with something off the top of your head. You're given a word bank or some sort of hint to help you figure these out. But let's talk about reasons for a moment. Reasons are any math definitions, theorems, or properties that you have previously learned in other math classes. Think about the different properties and the different definitions that you covered in Math 8 and in Algebra 1. Algebraic properties are some of the most common reasons used. The following properties, reflexive, transitive, substitution, and commutative, are the most popular choices. So here with our first example, now these are all reasons that I'm going to use in this proof. So the first thing we want to look at is our statement. Is our statement, did it come from some given information? Why, yes, it did. Right there. So for the first reason, we would write given. Now, in the second place, we don't have a statement, but we have the reason. The reason was given. Is there something else that was given to us? Yes, something else was given to us. Angle WLO is congruent to angle WMO. So that would be the next statement that we would make. Now, OW being congruent to OW, that's our number 3. That's something being congruent to itself. And when you were described this in Algebra 1 or Math 8, your teacher probably referred to it as you looking in a mirror. When you look in a mirror, you see your reflection. So this segment OW being congruent to segment OW would be the reflexive property. And then finally, we have triangle LOW congruent to triangle MOW. Now, I have no idea which one of these shortcuts it's going to be. Let's take a better look at what I have, and let's make some marks on our triangle. So LOW is this angle, and it is congruent to MOW, which is this angle. All right, angle WLO is here, and it is congruent to angle WMO, which is there. So I've got two angles. And do I have anything else that I can mark? Well, if I look at number 3, OW being congruent to OW, that's talking about this side right here. So I've got two angles and a side. So that means it's either going to be angle side angle or angle angle side, because those are the only two shortcuts or congruency theorems that uses two angles and one side. Okay, is my side in between the two angles? No, it's not. So that means it's going to be angle, angle, side. So example 2, I'm given that QT bisects SP and SP bisects QT. What does that mean? That means they cut each other in half. They cut each other in half. In other words, two equal pieces. So QT bisects SP, that's given. Number 2, my statement is blank, but it's given. Well, that would be SP bisects QT. Why is QR congruent to TR? So QR is congruent to TR, and That's because it's the definition of bisect. So if they're congruent, and then I want to say that PR is going to be congruent to SR, well, it looks like that's also reason of definition of bisect. All right, now I got a number 5 statement that's blank, but my reason is vertical angles. Vertical angles. Vertical angles would be right here. And so now let's name it. So that would be angle R, but we can't just say angle R because it could be either angle on either side. So we're going to say angle QRP congruent to angle SRT. And now, what shortcut am I using for reason number 6? I've got sides. I've got 2 sides marked and 1 angle. So if I look back, 2 sides and 1 angle would be side, 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 angle, side. Well, it's not side, side, side because there's no angle. So this one has to be side, angle, side. And last example, I'm starting off with a statement and it's given. So what am I given? Let's see, I'm given these 2 things. So where are those 2 things? Now, if I look here, number 4, that's one of my givens. So this is an example of where you start out with a given, but then you have some other statements in between, and then another given shows up. See that? So this is an exception. Sometimes this happens, and I wanted to make you aware of it. Typically, all of the given information does come first, though. So the measure of angle EMO equals 90, and the measure of OMY equals 90. So let's mark those in red. EMO and OMY. Why do they both equal 90 degrees? How do I know that? Well, does something up above it indicate why that would be so? Well, in statement 1, I said they were perpendicular. Perpendicular indicates 90 degrees. So if they're perpendicular, there's a 90-degree angle there. How do I know that? Definition of perpendicular. And the number 3 tells me that the measure of EMO is equal to the measure of OMY. That's the transitive property. And here's how you can do that. EMO equals 90 and OMY equals 90. So then EMO equals angle OMY. Sometimes you see this and you think substitution. And that's the one thing that can make proofs difficult, because depending on your choices, it could be transitive or it could be substitution. If you had written substitution in for me, I would have counted either one of those correct. M is the midpoint of EY, and that was given. And then number 5, definition of midpoint. So, what EY? Let's look at EY because that's what's being mentioned. So EY is here. Definition of midpoint. So if M is in the middle of EY, then that would mean that EM is congruent to MY. So let's write that here. EM is congruent to MY. OM is congruent to OM. Well, we've already talked about looking in a mirror. So this is the reflexive property. And now I'm looking for a shortcut. So when I look at my picture, I have marked a side, an angle, and a side. And is that angle in between those two sides? Yes, it is. So this would be side, angle, side.